Oh, something I should have mentioned is I highly prefer symbols to words. So when in doubt, use symbols. Except for in the last bit where I have fill in the blank, then you put words there. So anywhere else, do your best, if you can, to use symbols. Close. Well, do your best to try to wrap things up with your quiz, even though we're not collecting this. I'll give you about a minute more, just so that you can evaluate for yourself if you understand what's going on. And if you don't know the answer to one of these, it's fine. That's because This is to help familiarize you with how I'm going to ask questions in the future. All right, well, let's go ahead and go through this. I was kind of hoping Carson, but he knows what's going on. You can always share with him and do our best. Okay, so in each of these, we're going to do our best to identify the things in the stem of the problem that describe what is going on here. And I think you had homework that had both proportions and means. Does that look familiar? Maybe? Okay, yeah, whatever. Anyway, it's pretty similar. Once you, I mean, because what your job is, and this is really what my goal is for you, is to understand how to communicate with statistics. So that's why, who cares if you can compute the p-values? You're never going to do that. But to be able to understand what a scientific paper is talking about when it's talking about statistics is important. So anyway, what is the claim? So Irene thinks that she will make fewer baskets with her left hand than her right hand. So there's something about proportion being less than 60%. So that's her claim. She thinks this. She thinks that her left hand will be less than 60%. So something along those lines. And of course, I don't have the opposite of the claim here. I probably should have. So the opposite, just for my own help, is this. So you have the claim, the opposite of the claim. Then you want, now I'll tell you how to grade yourself in just a sec, but the null hypothesis will be that P is greater than or equal to 60%, and the alternative is that P is less than 60%. And as I've mentioned before, that symbol could either be greater than or equal to, or just greater than. So you can go either way with this, I don't care. Greater than or equal. Either equal or greater than or equal. Either way is fine. So there's my hypotheses. Here's how you should grade yourself. You should take off points if you're lacking any of these symbols. So if you've left off the P, that's a common thing. People will just say, alternative hypothesis, less than 60%. I need to know what is less than 60%. Is it P, or is it M, or is it X, or like, what is it that you think is less than 60%? Same thing over here. You want all the symbols, including the H sub 0. So everything matters. In terms of this could either be 60% or 0.6. So either one works. All right, left-tailed, right-tailed, or two-tailed. This thing is left-tailed. Whoops. Left-tailed because of that symbol. So it's always the alternative. You're looking that direction on the alternative. Alpha, you're going back up here to figure out what it is that we're interested in. That's the cutoff. When are we going to repack the parachute? Test statistic. Okay, so here's where things may be a little different than, I can't remember, it's been a while since I've actually done the homework. I've just looked at the problems as of late, because it gets a little bit boring when you do them every semester. So this here, that is the test statistic. The test statistic is the statistic that is computed either by Excel or by you. Back in the old days, I would have students compute this by hand. It's not that hard to get. But Excel is doing the work for us, and it is the thing that we use to evaluate whether or not this is unusual enough to merit rejecting the null hypothesis. So that's a stepping stone to get the p-value. The p-value is based on that. That tells us the p-value. So you can think of it this way. You don't have to, here, anything down here you don't have to have on your paper, but I just thought I'd put this here, is that you have this z. So the z statistic, the normal distribution, this, oh wait, it was negative, wasn't it? Yeah, negative. So what we're talking about is that we're back here. So in the standard normal distribution, you have the standard, you're 1.5 standard deviations below what you would expect. And you want to know, is that unusual enough to say, I don't believe that the null hypothesis is true? Because in the middle, that's where we put the null hypothesis. Okay, I'll blab less on the second one. P-value, hopefully you can pick this out. It's going to be, of course, based on this answer. This thing is left-tailed. There it is, 0.06482. Now here, things, because Newton, I know that they have you click, like you choose out of a list, but sometimes you're not thinking about the wording when you're like evaluating, is this one the right one, or you just, I'm going to get it right, get done. So let me explain how to do this. And when we get to the one on the right, we'll go much quicker. So here's what I'm thinking. Okay, maybe I'll go down here. The decision, this is G, and then I'll put the actual, all you need to write is what I put up there. So the decision is this. If the p-value is less than alpha, then you reject the null hypothesis. If the p-value is greater than alpha, then you fail to reject the null hypothesis. So up here, we're looking at this, and you can see here's the p-value, here's alpha. So a lot of students, when they get to this, they'll actually write down, this number is bigger than that number, just to, I guess, prove to me that they know what they're doing. You don't have to do that. I'm not going to, but you could if you want to, if it helps you to sort of put it on the page. But you'll notice that the p-value in this case is bigger than alpha. That puts us in the second category, and so I fail to reject the null hypothesis. Now I paused there because another common mistake that students make, and you'll have to evaluate whether you did this or not, because if you do this on an exam or on the next quiz, I will mark it wrong, is if you leave off that. If you tell me fail to reject, I don't know what you're failing to reject. You're failing to reject your boyfriend? I don't know. What are you failing to reject? So tell me what you're failing to reject. Finish your thought. Put H sub 0 there so I know, you're not rejecting the null hypothesis. That's what you failed to reject. What do you think, Elizabeth?
Why does it fail to reject it and not reject since it's bigger, so it's not ideal? I don't know. If it's bigger, then you,
So you want to know logically, like, this is the rule. Why is the rule this way? Is that what you're saying?
Yeah.
Okay, so, did I bring my deck of cards? I did not. Oh, drat. Wait, did I? Hold on.
Never mind. I hadn't looked in my brain when you first read it, and I was confused.
Oh, okay. But now it
did.
makes sense.
Yes,
yeah.
I'm
So
sorry.
if the probability that it's just by chance is low enough, that would be this. You'd be like, oh, it can't be by chance, because null hypothesis is the chance hypothesis. It's what you would expect if it was just all up to chance. So is it just chance, or is there something else going on? And it's always exciting when something else is, or no, I'm sorry. Yeah, this is, failing to reject null hypothesis, like, I guess it's just by chance. This is when it's exciting. Sadly, this one is not exciting. We're failing to reject the null hypothesis. Now, if you fail to reject the null hypothesis, you say that there is not enough evidence to support the alternative. So here's how I do this is, at least here, and just like with your quiz on the confidence intervals, I'm not going to give you this sentence like I did here on the next quiz or on the test. But I want to give you the framework and remind you how to write your sentence. So these two are only places I want to see words. I don't want to see words up here. Did you write words up here with the claim? Don't do it. It is painful for me to have to read words, so don't do it. And you don't want me to feel pain, because if I'm happy, then I give you higher grades. Okay, so there's not enough evidence to suggest that the true, so this is generally how your sentence is going to look, is that there either is or is not enough evidence to suggest something. And the something that you're suggesting, I'll put this in parentheses because, so this is going to be the alternative hypothesis. So where is the alternative hypothesis? Ah, there it is. That alternative hypothesis, don't give it to me in symbols down here. I want words. This is the only place I want words. It says the proportion or percentage is less than 60%. So let's see, what is it? What percentage? What proportion? Ah, it's the proportion, the true proportion of left-handed baskets is less than 60%. So there's not enough evidence to suggest that the true proportion of times, that sometimes it's hard to put something here that actually makes a ton of sense. I guess it probably should be a little bit more than this. The true proportion of times that whoever it is, Helga, I don't know who it is, makes a left-handed basket. So, but you understand what I mean here. And if you have something that is even peripherally related, I'm usually pretty good. I'm like, oh, I'm so happy that you are sort of in the ballpark. Like, it's like I said, it's painful to read so many sentences. I don't know how the English department does it. God bless them. And anyone who has to read a lot, I love numbers. Okay, but anyway, getting back to this. So let me pause and see if you have any questions about any of the structure of how I'm hoping you do your answers in the future. Because we want to get that structure down, because it's going to be, I think I warned you about this, that from here until the end of class, we're doing tons of hypothesis tests over and over again. And if you have this structure down, you're going to be in good shape. Yeah, what do you think, Oz? Sorry.
Is the conclusion always going to be about the alternative or about the claim?
It'll always be about the alternative, at least for us. So, yeah, I don't want to get into it, but depending on which textbook we use and so forth, it seems to vary how you want to write it. But it's confusing if it's about the claim, because if it's about the claim is sometimes the null hypothesis, in which case the way you write a conclusion about a null hypothesis is really convoluted. So it's much easier to just go with this and just write it. That's what I kind of like that about Newton. If you carefully read the way that they write it, you're clicking which of these is correct, and but it's always going to be about the alternative hypothesis. So yeah, you put the alternative hypothesis down here. Anything else before we look at the next one? Will go quicker, guaranteed. Okay, let me blow through the next one, but you pause, stop, or I'll pause every now and then. Okay, so we got Professor Axelrod claiming that the average salary is $71,000. So yeah, here the claim is the null hypothesis. So what is the claim? That the average is equal to 71,000 for Professor Axelrod's students, that is. I think I wrote this 10 years ago when 71,000 was like a big number. And now it's just like, well, I mean, I'm sure you'd be happy, right? But like my kids are making more than that. So, what's that?
It's livable.
Oh yeah, it's livable. This would be, yeah, you can live, especially in Ohio, you could live on that very easily.
California?
But yeah, no, not California. Or yeah, my kids are up in Boston, and yeah, that's a totally different situation. But anyway, so okay, I just blabbed and I told you I wouldn't. Okay, so null hypothesis, the opposite. This is not, I guess, unless I actually ask for it, you don't have to do it. Opposite, but it's helpful, is that it's not equal to 71,000. So the null hypothesis is the one with the equal sign. Make sure you write that symbol, that mu. I know it's a pain, but just make a U and put a little tail on either side. It's not that hard. Make a U, put a tail. 71,000. There's the equals, and then the alternative, you need all of these symbols to get full credit. If you don't have one or more, I take off points. This is a two-tailed test because the not equal says both directions. Alpha. What is alpha? Oh, 0.5. So this one, or 0.5. So 0.05 is in this, it's in the stem. The test statistic. So when you're doing means the test statistic will be a t. So, but it's always going to be given to you. I'm not going to make you compute that. That's too complicated to compute. Same thing with the z over here. You're not going to have to compute it. It's going to be provided to you. Same thing with the p-values. So you just have to pick it out of the table. Oh, this is t, sorry. T is equal to -2, what was it, 2.96. That's pretty big. Yeah, what do you think, Hayden?
Do we have to write the appropriate symbol for the test statistic, or do you just write the number there?
Yeah, my memory of grading these things is that if you just write this number, I'm so happy. I'm so thrilled. Yeah, so yeah, I guess if you're looking for the minimum response, let's see, what can I get rid of up here? You don't have to write the opposite, but I wrote it anyway. Yeah, so far this is the minimum. I'll stay with the minimum for Hayden and anyone else. P-value, same thing. You don't necessarily have to label it, but you have to pick the correct one out of the crowd. And here's the way I do this, by the way, is if you make a mistake here, I take off for this, like if you say it's left-tailed. But if you say it's left-tailed, you better pick the left-tailed p-value. So, you know, I kind of read with you, and if you make a mistake somewhere, then I'm like, okay, you think it's this way, even though it's not, and so I take off the points there, but I'll be like, you know, so if you do that, if you say it's left-tailed, and then you pick the two-tailed p-value, I take off both places, which I know you're like, wait, I got it right the second. Well, you thought it was left-tailed, so you should have picked the other one. Yeah, so it's 0.008 is the p-value, is 0.008. The decision is that we reject, but tell me what you're rejecting. Are you rejecting your girlfriend, or are you rejecting the null hypothesis? It's the null hypothesis. And then you have to write the complete sentence, and normally this will just be a big blank space down here that you have to formulate all of this, but in this case, since we rejected the null hypothesis because the p-value was less than alpha, we're going to say that there is evidence. There is enough evidence to suggest, and here I'll leave off the alternative hypothesis. So there is evidence to suggest that the true mean salary of Professor Axelrod's students is not 71,000. I know what you're thinking. It's clearly less than 71,000, right? But that's not what this hypothesis test was testing. From the get-go, wait. Sorry, I just have to double check. Yeah, from the get-go, the only thing that we're told is that Professor Axelrod claims students in her department receive an average salary of 71,000. And it says, we're testing Professor Axelrod's claim. So is it 71,000 or is it not? Now, clearly it's less than 71,000, but we're basing this all on the stem of the problem and what we're actually working on. And of course, you would be setting up, if you're a true scientist, you're going to set up this stuff ahead of collecting data. Well, you might have a hint. You might be like, you know, I know some of these people, and I think it's less than. But nowhere up there does it say that we're checking if it's less than. It just says, do we test Professor Axelrod's claim? So, so that's the correct way of saying it. So, anything else? Other questions about this? Think we got it? Yeah, what do you think, Hayden?
Well, I was looking at the p-value plugged into Excel, and it says such a right tail that we would not reject the null hypothesis because it's greater than.
Yes, that is correct.
That there's some that is, well, there's not enough data, or there would be some that are possibly greater.
Yeah, so I guess since since you mentioned this, I'll just mention a couple things about this. This p-value, left-tailed and right-tailed business, let's just comment on this quickly, is you'll notice that one of them, the two-tailed is always exactly twice one of them. That's always going to be the case. You can see over here as well, the two-tailed is exactly twice the left-tailed in this case. It's always exactly twice the smaller of the two. Another thing is that, the right-tailed, if you thought, like let's say you were testing the claim that, Professor Axelrod's students earned more than 71,000. If you got this data, this is clearly less than 71,000. Anytime you're doing a one-tailed test and your sample is on the opposite side of the null hypothesis than your claim, you've lost. So that's why this is so big. So yeah, you would fail to reject the null hypothesis and say there isn't any evidence to suggest that it's bigger. But yeah, but I give you all three only because that's the way we've been doing it. But typically, if you're a researcher, you would only compute the one that matters for your hypothesis.
Okay.
So, but I give you all three just because it gives you something to think about. Pick the right one. Make your conclusion.
I understand with the standard deviation that if you're looking like for different percentiles in the graph, you add standard deviation to the mean. So you figure out what percentage, and there would be one that you could add that would be greater than the 71. If you added 16,000 to 59, it'd be greater than 71.
Oh, so you're saying that there are people who are making more, but this isn't about individuals. This is about a collective, a group, saying that the average.
And it's not equal to 71, it's greater and less than that.
Yeah. So, and thank you, Hayden, for acting as spokesperson. Keep sending Hayden your questions, and he is happy to ask them. So thank you for that. Anything else before we go on? All right, let's go ahead and we're switching gears a little bit, not much. We're doing more hypothesis tests. But before we do this, I need to deal with a slight change to the schedule. I was looking at our schedule. I think on the syllabus it says the next exam is this Friday. And I don't feel ready for it. I don't know if you feel ready for it. So we're going to push it back if that's okay. So, so unless anyone is having a major complaint about this, this is a big change. Is exam 3 will be April 4th, which is not this Friday, but next Friday. So I wanted to make you aware of that, because this will just make more sense in terms of where we are, and also given that there's still quite a few weeks before finals, and this will be the last exam before the final exam, and it'll give you a bit more time to get used to how I'm going to ask questions. So if you do have a major problem with this, please do see me afterwards. We can chat. Maybe we can come to some sort of resolution. But I do believe that the syllabus does say somewhere that it's subject to change. So hopefully it won't cause too much trouble. Also, I think someone told me they couldn't be here on Friday. If that's you, maybe you can be here next Friday? I don't know. Yeah, the sporty people, you can let me know when your sport ball teams are going, where they're going. Okay, so let's go on though. So I know you're sick of this, but we're going over it again because, like I said, every single one, we've got the same steps that we do from here until the end. So I'm just reviewing real quick. We did them all just a minute ago. We do the claim. What is the statement that we're testing? We're going to take a look at a different, by the way, more hypothesis tests. We're looking at a different hypothesis test today, just slightly different though. So what's the statement that you're testing? What is the opposite of that claim? So take, see if you can figure out what is the opposite, and then do your null and alternative hypotheses. You know the drill. And then once you have those, that's going to inform whether you have a left, right, or two-tailed test. So this is all review. You probably got this written down somewhere, or if not, you can always watch the video. Is it recording? Yes, it is. Good. I always worry that I forgot. You're going to look for alpha somewhere. We did this already on that quiz. You'll see it. It's right there. I mean, these are basically the questions on, you know what the test is going to look like. You determine which distribution you'll use, and pretty much for now, actually for the next week as well, we're sticking with T and Z. If you're dealing with means, averages, then it's T. If you're dealing with proportions, it's Z. So that's the difference there. So just keep that in mind. Compute your test statistic and p-value. We're going to let Excel do this. And by the way, You know that hypothesis test gold spreadsheet that I hope you were able to work on while I was gone? If you didn't, you can come see me. I'll help you figure it out. But we're going to add to that. Like I think it's got 2 tabs on it now. You have means and proportions. And it's going to get, let me think, 1, 2, that's optional, 3, at least 3, maybe 4 more tabs. So we're going to be, hopefully you didn't lose it, because it's going to, yeah. So the Excel thing is what we're going to do for that stuff. Then you make your decision to either reject or fail to reject the null hypothesis. Oh, and by the way, let me just a minute. Let me go back to this. I just want to point out something. Last semester, I made a big deal. I know I keep talking about this, but I made a big deal about letter G here. And I think no one made this mistake. And it made me so happy. So, and I know that your job isn't to make me happy. Your job is to learn statistics. But I don't know, it just is so nice when no one does this. So like this, whenever I see this, honestly, I think, what are you rejecting? You know, like, are you rejecting Christ? I don't know. Like, what are you rejecting? So yeah, don't do that. Just tell me what you're rejecting. Tell me that you're rejecting the null hypothesis. Null hypothesis, okay? So that's part of the decision. So there's the decision. And then finally, the conclusion. And this will be a complete sentence, but we're going to be using this complete sentence so often, you're going to, just like with the confidence intervals, it's going to become hopefully second nature. You'll be able to rattle it off. You're going to be sick of me saying this same sentence. Today we're going to be focusing on a new hypothesis test. It's kind of a remix of an old one, but we're going to focus on just this stuff again. I know, we're backing up to this. And then on Wednesday, we will do the rest. Well, specifically, we'll do the Excel. So be prepared Wednesday to add to that the hypothesis test gold. So what is the thing that we're doing today? The thing is, the hypothesis test is this. We're going to be comparing 2 proportions and 2 means. These are means. Now, these are box plots. You're familiar with this. These are the box plots for test 2, and this is test 2. I believe this is the one that had this symbol at the top, and this is the one that had this symbol. So if you remember, when I gave you back exam 2, I mentioned this, that we had 2 different versions of the exam. They're really the same test, by the way. If you look at them closely, take a look at your friends, you'll see, oh, he just changed the order of the problems, or he changed this one number, which really is not going to change anything. So anyway, so they're really not much different, but it did startle me a little bit, to be honest, that this little x here is the mean, that the mean for exam 2 with the time symbol was about 89, and when I did the mean for exam 2 with the plus symbol, it was 82. And so the question that I have in my mind is, so the my claim is that the 2 tests are the same. There's no difference. And so the way I would write that claim, and this is going to take a little getting used to, is that the average for one of the exams is equal to the average for the other one. Now, you might look at that and say, clearly it's not true. Look, the average for exam with the time symbol at the top is bigger. But that's not what I'm saying. I'm not saying that the average that, you know, for what you got, I'm saying that if everyone, maybe every statistics student on campus took exam 1 and then took exam 2 or vice versa, that we compared the 2, everyone would get the same exact score on both exams. So it might just be by chance, this is where that chance thing comes in, maybe by chance I happen to give this version of the exam to students who are a little less well prepared than this one. I don't know. So statistically, I actually worry about this every time I give an exam because I don't want to disadvantage some students just by chance that they end up getting a harder exam. I don't think that was the case. Here's a couple of other ones. This is from previous years if you want to see. This is, so I took This is comparing two sections. This is from a group. And I believe that the top score, for some reason, the exam was out of 120. So that's what, but this is a similar situation where I'm comparing two sections. Here you can see that these are basically the same average. So the two sections got basically the same scores. Here I was comparing left side of the room to right side of the room. You know, like, I guess looking this way. So where do you sit? Does that affect? You know, these are questions. Front of the room versus back of the room. Does it affect your test score? So those are the sorts of things that we're going to be doing. We're going to be comparing two averages. And so let's get used to the language. I've got a, wow, they're all showing up at once. Well, there they are. So what I want you to do with these is to come up with one, the claim. In fact, let's go through the list. We're going to do the claim, the null hypothesis, and the alternative hypothesis. Maybe we'll throw the opposite of the claim in there as well. I'm just going to stretch this out while you're looking at those. You can read them over. And let's see if I can find what I'm doing here, just so that we have more room. So give me a sec. Oh, interesting. I think I was in the process of putting this on multiple slides. Okay, this will take a sec. Because I have four of the same slide. It's just all in a row. So I'll finish my job, apparently. It's weird. Okay. All right, there. Okay, so I've on the, yeah, you'll see. I fixed it. But on the next slide, I fixed it. Okay, let me do the first one, and then I'm going to back up to this screen again, just so that you have all of them. So the first one, I read this over and I say, okay, professor gives two different colored paper tests to determine if there is a difference between test scores on red or blue paper. You probably have had professors do this. I have a colleague who does this often. She'll have two different colors, and it just makes sorting, and students can look and they'll say, okay, I've got the blue test. I better cheat off that person who has a blue test. I'm just kidding. I don't do this. Well, I'll explain why in a minute. So if we just take a look at that, I'll put it back on the main slide in just a minute. Let's write down the claim. So I'll do this one for you, and you can do the other one. So the claim. Claim first of all. Get rid of that. Okay, so the claim. So always start with the claim. It says if there is a difference. So that to me sounds like you're trying to see, does a difference exist between the average test scores? So the claim would be something like this: mu sub 1 is not equal to mu sub 2. That's kind of like what we're looking for. Now, what is 1 and 2? If you really want to specify, this is slightly optional. And on the exams, I specify, because the calculations that we do when we get to Excel will depend on which color is number 1 and which color is number 2. So just to be clear, red paper will be number 1, blue paper will be number 2, but once again, when we get to Excel and on an exam, I will be very clear about how things are arranged so that you can get things, organized correctly. So there's this little deal here. Okay, there's the claim, and then of course the opposite is that the averages are equal. And what we're really interested in is the null hypothesis and the alternative hypothesis, and you will be so sick of writing this symbol, either you will have mastered writing the mu symbol by the end of today, or you will have given up and you'll just do something like this. I don't know. That's better than, I mean, seriously, that's better than some of the stuff I've seen in the past. Just put if you're confused about how to write it, just write a U and give me a little tail on each side. Oh, that kind of looks like a cow's udder. So it's like it's moo, moo. Okay. Well, anyway, I'll get rid of my weird stuff. So there it is. That's all you got to do. All done. At least for now. Wednesday, we'll be doing more work. But this is it for today. If we can master this, as well as with the proportions. So we'll have to do this with proportions as well. but not that hard. Okay, so the next one, the coach. Coach claims that athletes at her sport score higher on national math tests than non-athletes do. So I've got this separated over here. Take a minute to make sure you know how to do this while I get my randomizer fired up, and then we will see how you do. Random. Okay. So remember, we're doing three things. We're doing the claim, and we're doing the opposite, and then the hypotheses. You're filling in those blanks. Alec, you know what the claim is, don't you?
No.
So the claim that, so what is it that this coach is claiming? You can do it in words if you want, and then we'll translate to symbols.
Athletes in our sports score higher on a national math test than non-athletes.
Yeah, perfect. I guess you're just reading the sentence, but that's the claim. Yeah, that's exactly the claim. That athletes score higher. Higher to me means that athletes are bigger. So that's the symbol I would use. And then I just have to sort out some other symbols. How am I going to represent the athletes and non-athletes? Let's see. Let's get another volunteer here. Sienna knows. Sienna, what symbol do I use to represent the athletes? And what about the non-athletes? Yeah, the thing that you don't even want to say. You can just say moo if you want, like a cow. Moo. Moo.
Okay.
Yeah, moo. Moo. Okay, so you have this thing. Very nice. And then what is that thing? What is that thing gonna? What else do I write?
Like a 1, right?
Oh, sure. Yeah. So this one. So you're saying the athletes are group 1? Okay, good. So far, so good. Keep it up.
Oh, and then the non-athletes is group 2.
Okay. So I'll do that. This is moo 2.
And then get the
Drop that thing in there.
Yeah, the group.
Perfect. Perfect. So good. Excellent. Thank you so much. So so you've got the groups are numbered, and once again, this will be relatively clear when it comes to exams. I try to make sure it's clear as to which group, because when we get to Excel, it's going to matter which one is 1 and which one is 2. So you want to keep that sorted out. Okay, we've got our claim. Let's get an opposite of the claim. What are we? Ethan. Ethan knows the opposite, don't you?
Yeah, it's just the 1 is less than or equal to the 2.
Okay, very good. He doesn't even want to say it, but yes, it's mu1 less than or equal to mu2. That's okay. As long as you can write it, don't have to say it. So, very good. So, yeah, make sure you have all of those symbols. Now we'll sort out which one is the null hypothesis and which, of course, Biella. She knows it. She just had to go get more Kleenex. Let's see. But Hayden, you know it as well. What is the null hypothesis here?
So the null hypothesis, according to the claim and opposite claim, would be that mu of 1 would be less than or equal to mu of 2.
Perfect. Perfect. You're picking the one that has the equal sign in it. And as before, Newton omits the less than part of this. So Newton, you'll see it just says equals, but that's okay. It's okay. Either way works, and either way is fine with me on an exam. And then, of course, the other one is the alternative hypothesis. Not bad. We can do this. Okay, a couple more. Let's go back to, well, I'm not going to go back. I'm just going to go forward. Go to this one. Chaplain. So I'll get things set up, and then I'll pick my volunteers. All right, Joshua, you can do this, can't you? What's the claim here?
mu1 is greater than mu2, mu1's male.
Nice. Now, I just want to point out something that, and this might be the case on Newton, but sometimes it's convenient to do something like this. Mu_m is greater than mu_f. That way it's super clear that it's the males and the females. But I generally just default to the 1 and 2. But if you see it with little letters, just understand, that's fine. And you can use little letters. Honestly, I'm just thrilled that you got it sorted out correctly. So either one of those would be fine. Let's see. I've already bugged you. But Jesus, I haven't bugged. What's the opposite of this claim?
Mu1 is less or equal to mu2.
Oh, so good. And I like the way you say mu. Very nice. Okay, now we just have to sort out the null and alternative hypothesis. Anna, you know which one is which, don't you? Which one is the null hypothesis?
Mu is greater than or equal to mu2.
So I think I misheard you. I think it was less than or equal
Oh,
to, is that
yeah.
what you said?
Yes.
Yeah, I know. We're reading backwards. So, but yeah, this one is greater than or equal to this one. So herein lies the problem with sorting these out, is if you were naming these the opposite, like if you had the females first, then this would be switched around. That's why it's so important to get these straight. But yeah, very good. And then the other one, mu1 is greater than mu2. And once again, if you're taking a quiz or a test for me and you choose to use little letters like this, it's fine. I don't care. I'm happy with that. So if this makes it feel better to you, do it. All right, one more of these, and then we need to talk a little bit about proportions, but the proportions aren't that hard because you've already done these means. So the last one, the average number of hours workers are sick is greater in the week after the time change than in the week before. So, oops, clear. Let's see, claim. Sorry, I had to remember, what am I doing? Opposite. And then the null, alternative. All right, let me pick some people I know. So I'm distracted. Abby W. Abby W., what's the claim here?
I said mu1 is greater than mu2.
Very good. So this is the week, let's see, the week after the time change. So here, after the time change, I'm guessing is what you say is group 1, and group 2, or mean 2, is the week before the time change, number 2. So, yes, I'm still angry that I only got a response from one person when I emailed. It was, who was it? Now I forget who responded to me. Oh, I know, it's Bernie Marino. Bernie Marino emailed me back saying that he also cares about the things I care about. It was so comforting. I should pull it up. Maybe next time I should pull it up. But anyway, yeah, but no movement. I haven't heard anything in the news. In fact, it seems like I heard a news clip or a soundbite of Trump saying, we're not going to fix this. Why? Everyone would love you. Okay, but anyway. I even emailed him. Yeah, in my final, because I had to email 4 people, because 4 classes, so I emailed my representative, both senators, and then I was like, oh, I'll go right to the top. But he never responded either, sadly. Okay, let's get the, Biella! What's the opposite of this claim?
M1 is less than or equal to M2.
Very nice. And I like the way you say M, because if you change the font on your laptop to symbol, and you press an M, you'll get this. So if you ever want that, change to symbol. So that is the Greek letter mu, which is the M in Greek. Okay, final thing. You've already done something, and you're super smart anyway. Let's skip you. This thing, I wish it wouldn't repeat people. Carson, what do you think? What's the null hypothesis?
mu1 is less than or equal to mu2.
Beautiful. And then, of course, the alternative is the other one. This is basically it for your homework, is this and doing this with proportions. So you're going to want to do the same thing with proportions. Oh, I forgot about this piece. I've got a video. We don't have time for it. Yeah, I actually got dinged. Last semester, I showed a video, like a YouTube video, and I was streaming at the time, and I got a a note from YouTube saying, you have broken your terms of service by streaming this. And I was like, sorry. So when if we get to the video next time, it's such a good video. We'll do the video and we'll do, yeah. So just to be clear though, when you get your homework, you'll have proportions. I think you'll have proportions as well, where you're doing the same thing, but it's the same idea. You're asked things like, what is the proportion? You think that the proportion of freshmen who eat breakfast is less than the proportion of seniors who eat breakfast, that sort of thing. And you just set it up with P instead of mu. That's it. So I think that's, yeah, let's save the video for next time, especially since I can't stream the video. So when we get to the video, I'll stop the stream. All right, thanks for coming. If you want to come and chat, we can. We have a couple of minutes here. Otherwise, I hope you have a great day. Oh, stop the